All right, welcome back, and we're going to talk a little bit about piecewise functions now, because for some odd reason the kids fall to pieces when they get here. Haha. I know, I couldn't help it. I'm not going to sing Pax Decline, but I could. But then you might leave. So here we go. The thing about piecewise functions is the majority of the time the limit that's asked is a place, the x value where the graph breaks up into pieces. Notice that on the right side of this. Now let's do this. This is so helpful for kids visually. Let's put the 1 right there. That doesn't have to be quite that high. And let's say that if this is 2 for x is greater than 1, what we're seeing is that there's a parabola on this side and that there is a line on this side. Sometimes it's helpful to kind of put that on there so they can see which actual graph is on each piece of that break. So all we're going to do now is plug in 1, and if we do, we get -3. And if we plug in 1 here, oh look, we get -3. So coming in from the left and the right, they're approaching the same value, so the answer is -3. And sometimes that visual organizer that I just did for you is very helpful for kids. They don't understand what's kind of going on. So we're going to do the same thing over here. We have a little bit more of a situation here because we have, if you look at plugging 2 in, you have a vertical asymptote on both pieces of these graphs. So a little bit different, but this is to the right, x is greater than 2, so we're going to put this guy here. And this is to the left, so this is on this side. Now, because there are vertical asymptotes here, we're going to go with that thinking that I did in the last video of finding values very, very close on either side. So we're going to pick a value very, very close to 2, but on the left, let's say 1.99999, and then on the right side, we're going to do 2.0001. And when we do that, we're going to plug that into the perspective pieces to see what each piece of the graph is doing. If they're both going in the same direction, we can give that direction as our answer, and because that's a directional, does not exist. And if they're not going in the same direction, then we have to say does not exist. So what we're going to do is plug in the 1.999 and think about what type of answer we would get. Would we get a positive answer or a negative answer? And so if I put the 1.99 in the top, I'd get a negative, and in the bottom, I'd get a negative, and a negative over negative is a positive. So coming in from the left, the graph is going up forever. That's what that means. From the right, we're going to plug in 2.001. That would be a positive and a positive. Oh my goodness, look, from both sides, they're going in the same direction. So the limit as you go to 2 is positive infinity. And remember, guys, this means the limit does not exist, but both sides are going in the same direction. That's a very unique piecewise function. The other piecewise function I like to talk about is in the homework on page 31 in the Master Math Mentor, and that is finding a value of k that makes the limit and the 2 pieces actually equal. And what you're really doing is you're making it continuous. So, the limit and the function's value are equal, then you're making it continuous. This is another way to say find k so that the function is continuous. So you have a parabola, and they've just done this. They've just taken out a point. And so that's all they're doing, taking out a point. So what you need to do is figure out where the point is. So actually plug 2 in. And that's, I think it's -3, yeah. And so the hole in this parabola, because that's what they're making, they're just making a hole. Their hole is at 2, -3. Well, in order for these 2 things to be equal, you need for this, the y, to be equal to the y of this, if it could be there. You want it to fill in the hole. That's kind of what you want it to do. So normally there's an x in here, and you plug the 2 in for x, and you set them equal, but we can't do that because there's no x. So we're just going to set k minus 3 equal to -3. And if you look, wouldn't k have to be 0 to make that true? That's kind of a weird little problem. It works. In this case, you have the difference of squares. I just spotted that. And so if you plug in 7, you know you have a hole there. It's not a vertical asymptote. So we're going to factor and cancel. And the only reason I'm factoring and canceling is because I plugged it in first and got 0 over 0. There is a hole at 7, and it is at 14.
So I need this second piece to fill in the hole for these two things to be equal and for this function to be continuous. So I need k squared minus 2, because I couldn't plug the 7 in because there is no x in it, to equal 14. And if you add 2 and take the square root, k is equal to plus or minus 4, because you get 16. All right?